I'm going to get you started on this toothpick tangents part 2, and then you guys can just pause the video and finish it and then come back and pick it up. But when you guys get to this table, it's going to be easiest if you just let your calculator do the table. And so what you would do is in y1, you're going to put an e to the x, and then for y2, you're going to use the alpha window number 3, and that's going to pull up this symbol, and so you put an x, and then you're going to do y1. So to get y1, you have to get the variables, and that is going to be alpha trace. And I'll show you how to do that in just a second. And then you're going to do x equals x. So let me show you on the calculator. Sorry, I have a bunch of stuff pulled up. Here we go. All right. So to get e to the x, we're going to hit seconds and then ln and then x. All right, and then to get the derivative function, you do alpha window number 3, and our variable is x. And what we're wanting to graph is the slopes of e to the x, and so we're doing the derivative of e to the x. And we could type e to the x in that would be fine. A little bit shorter way is to do alpha trace and choose y1. So whatever is typed in y1 is going to do the derivative of that. So in this case, it's the derivative of e to the x. And then if we do just let x equal x, when we go to our table, which is what I would do to fill in number 3, there it is. So y1 is e to the x, and y2 is the derivative of e to the x. So I'll let you figure that out on your own. And then same thing for number 6. So go ahead and pause the video and do that front side, do the toothpick tangents part 2, and then pick back up. All right, so what you should have found by doing the front side is that e to the x is its own derivative. So the derivative of e to the x is e to the x. So all those values give you the slope at that value. It's kind of crazy. And then hopefully you also figured out that the derivative of ln of x is 1 over x. Okay, so for our checks for understanding, the first one, we're going to find f prime of 3. Before we can find, and we're not using the calculator anymore, the calculator we just used to figure out that one problem, to figure out the rule. Now we're going to do it by hand. So to find f prime of 3, we're going to first find f prime of x, find the derivative of f of x. All right, so I'm just going to take it one piece at a time. So we'll start with the derivative of 4e to the x. So since the derivative of e to the x is e to the x, the derivative of 4e to the x is 4e to the x. All right, and then we'll go to the next question, or the next term. We'll find the derivative of minus 3x. That's just going to be negative 3. And then lastly, we'll find the derivative of 2 ln of x. Right? So the derivative of ln of x is 1 over x. So the derivative of 2 ln of x is going to be 2 over x. All right. And then we aren't quite finished. So the final answer to find f prime of 3, we are going to have to take 3 and put it in for all of our x's in f prime of x. We're going to find f prime of 3 by making all of our x's 3. And we're going to leave it like that. There is no reason to do anything else. So without a calculator, we don't know what e to the third is. And if we were going to use a calculator, we could just do that shortcut like we talked about over here, the alpha window 3. So this would be a non-calculator question. You would have to leave it like that. All right, and then for 2, for what x values, if any, does y equals e to the x minus 4 have horizontal tangents? So remember from yesterday when we did horizontal tangents, we were looking for where the slope was 0 or the derivative is 0. So the first thing we want to do is find the derivative. All right, so when we're looking at the original equation, y, when we find the derivative of e to the x, it is e to the x. And then the derivative of negative 4 is 0. So that is it. So we want to find when e to the x is equal to 0. So think about what we can raise e to, a number 2.8. What we can raise it to and ever get 0. Is there a number? There isn't. So no x value will make e to the x equals 0. So that means, therefore, there are no horizontal tangents. And that's fine. There doesn't have to be. So the horizontal tangents occur at like the top of a mountain or the bottom of a valley. If you don't have mountains or valleys, then you don't have horizontal tangents. So if we look at e to the x, e to the x minus 4 is taking the e to the x graph and moving it down 4 units. We don't have hills and valleys, so it's not going to happen. All right, and then for 3, we are going to give the equation of the tangent and normal lines to the graph. G of x equals natural log of x plus 3x squared when x is equal to 1. Okay, so don't forget that when we're doing tangent lines, you need 2 things, and same thing for normal. Well, most of the time we do tangent. You need the slope of the tangent, and you need the point of tangency. All right, to get the slope of the tangent, we need the derivative. So we're going to find the derivative. So the derivative of the natural log of x is going to be 1 over x. And then the derivative of 3x squared is going to be 6x. All right, so our slope of the tangent line is going to be g prime of 1. That's going to be 7. Okay, then we need to find the point of tangency. And when we're finding the point of tangency, we go back to the original g of 1. Okay, I want you guys to know what the natural log of 1 is. So natural log is log base e. So you're figuring out e. So what power gives you 1? Well, e to the 0 power is 1. So that's 0 plus 3, which is going to be 3. So that means that our point of tangency is the point 1, 3. Okay, so this is the slope of the line, that's tangent. This is the point where they touch each other. So we're ready to give our tangent line. All right, so this goes back to point slope form. So I'm just going to remind you So y, so this will be x1, y1, this will be m. And you're done. Don't do anything else. Stop right there. Okay, and then don't forget, normal lines are perpendicular to tangent lines. So they have the same point. They're just going to have a different slope. The slope is going to be the opposite reciprocal of 7. So negative 1/7. And then stop right there. You're done. All right, now number 4 is kind of tricky. All right, so in the xy plane, the line negative 3x plus 9y equals k, where k is a constant, is tangent to the graph of the natural log of x. We want to figure out what k equals. So to figure out what k equals, we are going to need to know the slope of this line. All right, now there was a shortcut you guys learned maybe back in Algebra 1 that if you have an equation in, it's called standard form. We don't use it very much. So the standard form of a linear equation is ax plus by equals c. If you wanted to find the slope, it's the opposite of a over b. So if we wanted to do that for this one, well, we could go back and say a is going to be negative 3, b is going to be 9. So the slope of the tangent line is going to be negative 3 over 9, or negative 1/3. All right, so what that means is that the slope, wherever these touch, we don't know, wherever these touch, the slope of y equals natural log of x is also going to be 1/3, because tangent line matches the slope of the graph at the point of tangency. So what we would want to do is go ahead and find the derivative of y. So the derivative of the natural log of x is 1 over x. All right. So at the point of tangency, the derivative, or the slope, needs to match the tangent line slope. So 1 over x is going to equal, I didn't do the opposite. I'm sorry. All right, so we do the opposite of negative 3, which will be positive 3. My bad. I'm sorry. All right, so at the point of tangency, 1 over x is going to equal 1 over 3. So we can deduce that x is equal to 3. So that's the x value of the point of tangency. Then we need to figure out the y value at the point of tangency. What do y'all think? Anytime we know the x value and we want to find the y value, we go back to the original. So we go back to the original and find the y by plugging in 3. Now, because we are not computers or calculators, we don't know what the natural log of 3 is, so we'll just leave it like that. So I know what x is, I know what y is, but that isn't what the question is asking. The question is asking, what is the value of k? So look at everything we have and look at what we want and see if you guys can figure out a way to get what we want. Right, our only equation that has k is that purple one, negative 3x plus 9y equals k. So we have the x and the y at the point of tangency. So I'm going to plug those in. And that's going to be k. And I'm going to leave it. Like, this would possibly be on a free response question. And so just leave it. Leave it. They don't care how messy it is. They want you to know the calculus. They don't want you to know the algebra. So all I did was take what x equals, which was 3 at the point of tangency, and what y equals, which is natural log of 3 at the point of tangency, and plug that in, and that gives me k. All right, so your assignment is going to be topic 2.7 worksheet.